Today we are out in the garage and it is December 26, 2024. And behind me here is our 1994 Dodge Ram 3/4 ton four-wheel drive 5.9 liter Magnum V8 gasoline engine. This truck is a regular cab long box and I've owned this truck for 19 years. I bought it fall of 2005, and in that time I have put on roughly 25,000 miles. I still like this truck. I like using it occasionally. I typically run 1 to 2 tankfuls of gas in it a year. I store it in the wintertime because if this truck sees any more salt, it's just going to completely rot away. There'll be nothing left of it. It will melt. The last couple of years, I've had a little bit of an issue with the transmission. And I bought this truck in 2005 with about 150,000 miles on it. I was the third owner at that time. And the person that I bought the truck from purchased it at about 3 years old with 50,000 miles. And when they purchased the truck new, or nearly new, at that time it had had a replacement transmission. So somewhere around the 40 to 50,000 mile mark, somebody had a transmission failure on this truck, replaced it, got rid of it. The vehicle is old. It's 30 years old. The transmission itself is probably 27 years old. Even just using this truck locally, I don't want to be in a situation where the transmission ends up going out, failing, where I have to tow it back. And if I'm towing the boat or the jet skis or whatever the case may be, it's an old truck, but I would like to try to keep it maintained in the reliable category. Without getting too far into the weeds on this truck, I wanted to sort of highlight what was going on with it and why we are going to be dropping the transmission in the transfer case and doing repairs on them. Not just necessarily based on age, but also based on the current working condition of this truck. So 2 years ago, I dropped the transmission pan and did a transmission service. And unfortunately, I don't really remember the last time I did a transmission service. It may have been quite a while ago, like maybe 2007, 2000. So 2 years ago when I dropped the transmission pan and, did the fluid, I was not having any drivability symptoms. So what I went ahead and did, I dropped the pan, I adjusted the front band and the rear band. And the rear band on this transmission, which is the 46RH, was adjustable inside the transmission pan. And then the front band is adjustable on the outer portion of the transmission without having to, remove anything or drop anything. So when I dropped but there was a substantial amount of gunk or debris that was in the pan. And it was more than I was expecting to see, because, you normally drop the pan, you see some gunk around or some metal magnetic fines around the magnet. You might see a little bit of, kind of minor sludgy material, aluminum material on the bottom, fines that kind of collect, and you wipe it up and the fluid overall looks good. In this case, there was a substantial amount of gunk on the bottom, like maybe 1/2 inch to 3/4 of an inch. There was some bigger chunks. There was maybe, it looks like to me, clutch material. Overall, it wasn't good. And so I was a little surprised, but I went ahead and I changed the filter, put new fluid in, put the pan back up, drove it. Everything worked great. The transmission actually shifted really nice, and brought it back, and it was actually time to put the truck in storage. Put it in storage, left it. And the next year, it'd be this past year, I pulled it out, and the truck would not, it would shift into, we would start off in first, go to second, third, fourth, that all worked fine. But once the transmission warmed up, it would not shift back into first gear. It would be stuck in essentially like second or third gear. If I manually shifted down to first gear, the truck then would start off in first, and then I could shift up into drive, and then it would continue its normal shifting operation. At this point, you know, I looked at the fluid. The fluid looked really nice. It was at the proper level. I don't know. I continued to drive the truck. I was leaning on the governor assembly being stuck. Like there was something going on with the governor. This is the 46RH transmission, so it doesn't use the electronic pressures. It's, you know, all hydraulically controlled with a mechanical carousel on it. I continued to drive it, and, you know, the problem in some ways kind of got worse. There would be some level of normal operation cold, and as it warmed up, it just flat out wouldn't work. Now, this all changed when I drove about an hour and a half on the freeway without stopping to go pick up a pair of jet skis. And I towed the jet skis back with this truck. However, when I stopped at the location that I was going to pick these jet skis up, the transmission appeared to be operating normal again. It would downshift the first gear, first, second, third, fourth. Everything seemed fine, except there would be an occasional flare where it would go first gear, second gear, and then it would quickly flare back to first and then go back to second, and then it would continue the shift on. So that is what I'm dealing with right now as far as the transmission operation. And I'm combining that with the age of the truck being 27 years old, the fact that I would still like to maintain this as a reliable piece of transportation, hauling my various items, including I would like to at some point haul a skid loader. I think it's more prudent at this point to drop the transmission and transfer case, tear them apart, figure out what they need. At minimum, they're going to need clutches and a soft kit. Maybe there's some hard parts that are worn out. I don't know. We're going to take it apart, see what's going on with it all, make a list of items that I need, go ahead, get an order in. Okay, so we're at 174,754. And, you know, considering these trucks, you know, back when they were new, the transmissions were not the strong point with them. I would say, you know, 125,000 miles is not bad. The transmission works. It's got a kind of a goofy flare from 1.2 back to 1 and then to 2. It hauled the jet skis perfectly fine. It didn't seem like it was slipping. It still works, but I would like to bring some reliability and trust back to this transmission. Go ahead and get everything kind of freshened up. The transfer case on this seems to work okay. I was under the impression that this transfer case was a shift on the fly. However, it does not operate that way. It never has for me. So it'll be interesting to see if indeed this is a shift on the fly style transfer case, or if there is some blocking rings that are ground up. The half case on it is leaking pretty good. It always has leaked for me, but now it's at the point where it's leaking pretty good. So, you know, at minimum, it needs a reseal, and at most it's going to need probably some hard parts replaced. But we'll go ahead and tear that apart and see what's going on. All right, what we're going to do here is I'm going to disconnect the shifter linkage for the transfer case. And while we have it here, I'm going to take out the drain plug, and we'll drain off some fluid. We'll get the rear drive shaft off, transfer case out without dropping it. Got some stuff down there. Don't know. Be interesting to open that up. I don't. Almost to me it looks a little bit copperish. Right there. So, all right. So got the emergency brake on, and I'm going to take this drive shaft out now. All right, we've got 3 out of the 4 bolts out, and unfortunately, the 4th bolt is not coming out very easily. So, the main goal right now is just to get the drive shaft out. What do I got here? All right, so our next plan of attack here is we've got this transfer case that we need to remove. Position here with this.
Oh, shoot.
It's all right.
Okay. Concrete.
Yep.
EPA can't find us.
Okay, I am now balancing. Don't do anything yet, though. Okay. All right. Now I want you to slowly see if you can lower it.
I can't spin it.
Okay. Okay. Oh, it's starting to slowly go down. Okay, good. You're doing fantastic. Just let it do that. Okay? Yep, just let it do that.
Do I need to fully go down?
Nope. Okay, now I want you to pull. Oh, hold on a sec here. All right, pull. Okay.
We'll have to start turning.
Yep. Pull. All right. Perfect. All right, now we can. Yep.
Perfect. Not working for you.
So it was not that long ago that I did a service on this, and the whole bottom is, you know, it's already got sludge in it. You know, was it left over, suspended in the you know, the remaining fluid? And all right, we need to take the exhaust off, and we're gonna try to do this here without causing too much heartache. All right, what we're going to do here is I'm going to get the jack under the transmission. I'm going to take this mount out, and then that will free the converter, you know, so that I can drop it down further and move it around. And then I'm going to zip this connection off. It's kind of welded here, and I think we can just kind of zip this pipe so that it loosens up and opens up nice. I am most likely going to end up replacing this. Okay, so we have we've got the transfer case shifter removed. Got the cross member out. We have the exhaust out of here. I drained the transmission fluid, put the pan back on. So now the next step here is I'm going to disconnect some of the ancillary items here that are connected to the transmission, like we have cooler lines, shift linkage, got a starter, and you know, all sorts of just random stuff that are connected to this transmission. Once that is done, I think that will be it for tonight. We're gonna drag this into probably a third half day. So I started this about noon on the second day here. The first day I got the transfer case out with about a half day's work. So right now, as it sits, We've got a good 8 hours into this project, and mostly that has to do with the fact that everything is just so crusty. I'm trying to take this apart without stuff breaking, but it's not really relevant either because some of this stuff is going to have to be replaced, like hardware and stuff like that. So let's get to work here and we'll get this stuff disconnected. My what?
Bolt spin. I love this thing. Do you buy these tools all by yourself, or are these from being a mechanic?
Yeah, I bought them all. Some of them were in the, so I bought the toolbox used,
Okay.
and it came with some tools. Some tools I got a scholarship from Snap-on,
So they were free?
and so I got $2,500 in Snap-on tools. Some of the Snap-on tools I bought.
Doesn't sound cheap.
What's that?
That doesn't sound cheap.
No, it wasn't.
Why are they so expensive?
They're considered a premium tool, but
Or is it just
it's
cheap?
kind of gone to the point of where it's slightly ridiculous.
Well, like, the common asked question to the mechanic, you see on those YouTube videos, is how much did you pay for your tools? Or how much Snap-on debt do you have?
Right.
And they're like, I have about 1,400. Some said like 15,000.
I'm going to. All right, so you're not going to do anything right now. You're just going to be. You remember how to twist? Right is to tighten
Left
it.
is
Left is to loosen it. And you're just going to listen to my commands.
Is the transmission basically about the same amount as the one on here? Or will it be a little bit?
This is going to be bigger. But I think we're pretty much balanced on it.
It shouldn't wobble.
And so,
Is this also lifting the truck up?
no, the truck is on its wheels. So we don't,
But what if the suspension looks like it brought everything up?
well, the engine's resting on a jack stand.
The engine?
Yeah.
It could fall out?
No, it won't fall out, but it's just to kind of keep it where it needs to be. Goodness. Oh, this bolt is being a PETA. Woo!
What?
Tight.
Very close.
There. We're getting there. I don't like that. Woo. Okay.
I just got a paint.
Yeah.
Is it rusted?
Not yet. Yes, it's resting, but I'm concerned. All right.
Yeah.
I want you to lower a little bit. Don't stand behind it. Don't stand behind it.
Twist it.
Okay, which direction are you twisting?
Left.
Away from you?
Yeah.
Okay, I will help here. Okay, just give me a minute. We gotta do something here. This is... Okay. Want you to... All right, it's loose, but go very slowly to the left. Or stop. Woo! Stop. Tighten it.
My bad. My bad.
Okay.
My bad. Shoot. If it was so loose, I wasn't expecting it.
Okay, no problems. All right, I want you to go down a little slower now.
Is it lowering?
Not yet. A little more. Okay, we're going down.
What's that noise?
It's going down. That's what. So you can go a little faster. There, right there.
Woo!
Okay.
Engine stable.
All right. Now this is going to be
Hard part.
the fun part here. We're going to let that rest for right there. I need to find like a board. Yep. All right. Get the jack out. Perfect. All right. We're gonna make our life a little easier.
Jack is.
We're gonna make our life a little easier. So this is the torque converter,
Okay.
and it just slides out.
Okay. So that's why people were saying it was at 39 pounds with torque converter.
Yep. Okay.
Okay, this looks a lot more light.
Oh, just enough clearance, maybe. I need.
No,
Let me
it's
see.
not. It's not.
What if I get rid of the board?
But then we sacrifice.
Well, it's gonna have to.
What are we doing? Fit under if we just went a
Yeah, I
little
know.
more to the left.
Sometimes you gotta just stop and think.
Look how happy and he was sad. He was like, glad to do business.
Got rid of
Got rid of equipment that probably wouldn't sell.
For me? Do you like my sweater?
I do.
250-pound transmission.
That's it?
That's it. It's
How'd you guys drop it?
the jack.
Very careful. You're supposed to say very careful.
Yeah, very careful.
Alright, so why don't we use the jack to
Yes.
lift it back up?
Well, we can't. That's not gonna lift it that high.
But it, okay, so
So this is the heaviest end.
what is,
My end.
okay?
I don't know. Ed might.
I'm here to.
Much.
Love you.
Window strength.
All
You
right.
got a plus 10 strength bonus from lifting windows.
Crazy.
I love you.
Love you too.
You guys are amazing.
There we go, there's the pump. All right, so I think this has definitely been a part. There was caulk stuck to this, and it was kind of hanging out down here. So there's our magnet. Definitely has some magnetic fines on it. Here is the feed tube that went to our pump. And of course you can see here, I don't think this is factory. Someone can correct me if I'm wrong, but there is just a gob amount of RTV, and as I stated before, this had ever since I bought it, which is 20 years, it's had a very minor case leak at the halves. So what do we got here? Got goes there. This is interesting. Have the case separated on our transfer case, and right now it looks like I have this in two-wheel drive because we have the main input shaft that is working here, and we got noises. Aside from the case leaking, the big issue that I've had with this transfer case is that my understanding is the 241 DLD is supposed to be shift on the fly. And I have never in the 20 years that I've owned this truck, 19, have been able to do anything remotely close to shift on the fly. Even at 15 miles an hour, it will grind gears. It literally does not work. I have to physically stop the truck, then I can pull it into high and do what I need to do. And based on my research, that is not the way this transfer case was designed to function. And I honestly would agree with that statement because it was designed with synchros. And the whole point of synchros, if you've taken apart a manual transmission, it's to mesh the gears together so that you can go into gear without it grinding together. So right now, as we sit here, we are direct drive, and so that would be two-wheel drive. We got something kind of making noise here. Generally, I didn't have a problem going in and out of four-wheel drive. Once in a while, it would sort of act up, like it might make a noise going into four-wheel drive, or it might make a noise coming out, but for the most part, it's always kind of worked, except for the shift on the fly. But let's do this here. We're going to shift it back into four-wheel drive. So that right there would be 4 high. Okay, and got the synchro there that meshed that way. And then if we go down here, this is going to be low. We got a sun gear down there turning. This is interesting. Is that not fully engaged? Maybe we're not fully engaged here. There we go. Now we're fully engaged. Okay. Videos of other chains, this one's not the worst that has ever been out there, but because I'm going through all this effort, it sort of makes sense to replace it. It seems harder to find. Like the heavy duty, the DHD chain is a lot easier to find than the DLD, so I got to work more on that. don't need to take that out. Take this out. That all looks decent. Oh. That doesn't look good. That all looks pretty decent. Oh, what I wanted to check is this. Why do we grind? Why do we grind? This seems to go on one direction and one direction only. And let's see how it is on this. Let's try something here. this snap ring back. Something's not right here. So go like that. This. Okay, so we can clearly see this was turned around the other direction. There, that went that way. But if we go this way, I really think it has to go the other way because these are beveled, these teeth, which would line up with operating sort of as a synchro. Right here we got the synchro right here. So if it went this direction, so we're spinning. It would be like I want to shift. It's tight. Is it just too far? Is that what the deal is? Too far. Go like that. Lock. Alright, that really doesn't help me. I'm gonna have to research this a little more. The only thing I can think of right now, without researching this a little bit more, is that synchro is just worn enough that, so like there's a little bit of wear here, and I know this inner ring acts as sort of a brake, and then we would push and the shifter would push, and then this would essentially, you know, mesh it up. So we would spin and then it would stop. Plan of attack going forward here. I need to research a little bit more on this transfer case with this blocking ring. As far as, these are off-the-cuff theories. I know some of you in YouTube land have difficult time understanding that, you know, we don't just come to a piece of equipment with full knowledge and just do it, you know, just boom, overhaul it. I suppose if I overhauled these on a daily basis, then that would be the case. And for those that do, you know, congratulations. However, this is the first transfer case that I've had apart, and although I've done numerous transmission jobs before, this is the first transfer case. So I am trying to understand why this transfer case will not do shift on the fly. Never has. The beveled teeth right here go down, and our shift fork is right here, which is ultimately connected to the lever inside the truck. And so as we push, this is going to be, okay, so that's one way. These little teeth, these paws, well, I'm going to call them paws. I don't know what they're technically called. All right. Engagement paws for the synchro. And the synchro is the brass colored item in the gear set here. Okay. And that's what engages sort of like a drum brake, and then at the same time allows the shifting ring here, again, terminology, to engage over and create an engagement so that it operates as one unit. What I don't know exactly. Everything looks like it has been assembled correctly. I'm gonna go do some more research on these paws. If they're, I think they're in the right spot. I just really don't know what exactly is going on. My theory here is that quite a few years ago I had a Eagle Talon all-wheel drive turbo, and it was a 92, and those vehicles had problems with the synchros. Usually it was like second and third, and as you can imagine, you know, a car like that, you'd be ripping through first to second, second to third, and of course those synchros were always the first to kind of go. What I did was, in that transmission, I remember tearing it apart, and I had definitely some issues, like the bearings were not good. I went ahead and I replaced all the bearings in the case, but the synchros themselves, I remember sort of, you know, looking over, and they just really were not obvious on why they were not working. And I have to wonder if this is the same situation. So what I'm going to do, I'm going to go and see if I can source a new synchro. I'm not entirely sure I can, or if it's, you know, cost prohibitive. I'm going to do that, and then I'll research to see if there's something that I am missing on this, but I don't think I am, because I believe this is assembled correctly. It looks like this is shifting correctly, and it's kind of doing what it needs to be doing. It's just literally, you know, the synchro is just maybe just a little bit worn enough where it's just not doing what it needs to do. And I don't know, you know, maybe it's misshaped. I don't know. So we'll see. If I can get a synchro reasonably, I'll do that. And then the second, all right, we're gonna disassemble this transmission here. Let's start with pulling the belt body. Little snap ring right here that we gotta pop out. All right. Filthy, absolutely filthy. 500 miles on that filter. All right, we've got this out of here. So pretty grungy. Pretty grungy. I'm gonna make a separate video about going through this. I think there's some upgrades and parts and stuff that I can source for this, and I'm gonna go ahead and do that. Overdrive unit is here. I think we can take that off first to sort of lighten the load a little bit, per se. So that's what we're going to do. I'm going to take All right, I think we have all the bolts out of the overdrive unit. There we go. Surprisingly, this is still, these seals aren't bad. I mean, these at least are still somewhat pliable. So this will be, we'll get new seals in this. What a mess. All right, this is the front pump. We're going to take that out next. Clearly we had some oil getting flung around. I'm definitely putting in a rear main seal on this. sloppy. Got tools everywhere, training fluid everywhere. All right. We are going to disconnect. Okay, so that is still alive. All right, here. Oop. Zip off the snapper. All right. We got a sun gear here. All right, let's jump to our clutch assemblies here. I do not remember which one is which and what do they call it. I will, as we reassemble it here, I'll go ahead and read the manual. I did purchase a manual for this. I always read the manual for a transmission that I haven't really overhauled before. And of course, haven't done it in a while. In this case, I have not done a 46RH before. Obviously, I've been around people that have done them in the past. So this is not like a completely foreign transmission. But nonetheless, I don't know it to the depth of like calling this the forward clutch assembly or something like that. So I will go ahead, I'll read the manual, and then as we reassemble it here, I will sort of explain what we have. This is just kind of an exploratory process right now. I'm trying to get a good understanding if I need to, if I'm just going to put clutches and a soft kit into this, or if I have to buy some hard parts. I'm definitely buying a new torque converter, but beyond that, I don't know what hard parts are actually going to be needed on this until we, get it apart and look. Okay. All right, here. This is what I've been waiting for. So, okay, so we got here 1, 2, 3, 4 clutches. Is that right? Just sits there like a spacer. It's plastic. Okay. There we go. Okay. Yeah. There we go. These seals are still good. All right, so these clutches look brand new. Okay, now I remember this. We're gonna deal with this a little bit later. I need to put it to the press and clamp down so I can remove the snap ring. And then I believe there is a seal on the inside here. So we'll take care of that at a later date. We'll just continue our disassembly. Got a snap ring, of course. Snap ring is out. This is out. Oh yeah, the roller cage. That fluid is nasty. So, okay, what do we have left here? I think that's it. Other than we got to clean the case up. The case is absolutely disgusting. Not entirely sure how I want to do that. So, okay, what we're going to do here, I'm going to stop this and I'm going to clean up the bench. We've got our transfer case over here. And we have our transmission right here along with a pile of tools. I need to get this cleaned up so we have some more bench space. We're going to take apart the overdrive unit. And then I think there was something that I needed to press so we could compress the springs so we could take snap ring out and get further into it. So let's do that. overdrive. These actually don't look that great. Oh. Okay. Well, I think that's what we have to do. All right. A little bit of wear on the bushing. Clutches look nice. Very nice. It's got 1, 2, 3, 4, 5, 6, 7, 8. 8 clutches. Okay, so we are dealing with the 46RH A518 transmission, and today we are going to disassemble the valve body, and I have some upgrades that need to be done, and we're gonna follow the directions on that and hopefully come out successful. Got a drill bit, all sorts of All right, so this is the Sonnax 4647 RHE zip kit, and it's meant for the 46RE, RH, 47RE and 47RH. There is the part number. And we have various different items. Fascinating. Ooh, check balls. Okay. got here? All right, that loosened that right up. Oh, look at that. Isn't that all disgusting? Yikes. Okay, so got a little screen in here. This smells horrible. Absolutely horrible. Then we got the check balls. So at minimum, I'm thinking this thing just needs a flat out good cleanup. Of course, we're going to apply the zip kit. All right, step one, replace line pressure plug in sleeve. Components are designed to replace an OE 3-piece line pressure plug in sleeve arrangement. If an OE 2-piece design is found during disassembly, alternative components not included may be required. Place O-ring into groove, lubricate with Sonnax slippery stick O-lube, and roll on bench to size. Push Sonnax sleeve into bore, blah, blah, blah. All right, so we're gonna go to diagram 1. Replace line pressure plug in sleeve. Figure 1, which will be right about here. Remove parking spring and throttle pressure adjusting screw bracket and install throttle valve lineup. For ease in removing, installing parking spring, use small woodworker step gouge awl to compress detent ball and spring. Ooh. That popped out. This plate over here had a check ball that just popped out, and I, for the life of me, could not figure out where it came from. In the diagram from the zip, you know, it wasn't making a ton of sense. Anyways, the diagram for the zip had two check balls. They had one here and then one somewhere, like I believe right here. And after looking through the manual, the transmission, the ATSG manual, they were indeed showing a steel check ball here and a steel check ball here. There was only one steel check ball in this, and this transmission was rebuilt. I don't know where the steel check ball was, so it gives me, you have a couple diagrams right here, and it says number 8, blocks line pressure from entering the rear forward clutch circuit when the selector is placed in either park, reverse, or neutral. And number 9 is forces rear band to apply oil through an orifice for smooth reverse band engagement. So in park, reverse, neutral, it always had sort of a strange fluid sound. That's possible that was not there. But the other issue is and this has a plug in it, so that is going to be replaced. So this plug goes right there. And then we have 2 O-rings. One is a spare, I believe. Okay, we put the O-ring on and get some transmission assembly lube out. Okay. Okay, and this goes like that. All right, so we got that in. All right, we are on to number 2, which is remove parking sprag and throttle pressure adjusting screw bracket, install throttle valve lineup. And here are the parts. Got let's see what else we got here. So that popped out. And there is one more valve. One more valve down there. All right, I need to get a screw. I don't know where that came from. All right, we are going to assemble this just as the directions have it. Optional, see chart. All right, So we got 3 shims here, and we need to see the chart. What chart am I looking at? Oh, here we go. Higher up shifts. Spring and shim usage for desired change in TV pressure. So 0 would be 0 PSI. Sonnax 1, 2, number of shims. Change to TVI. You know what? I think I'm going to bump this up to 14 PSI for the TV pressure. Why not? Seems like a good idea. Doesn't it? A little bit more pressure. Firmer shift. Okay, so then we have our spring. And then we have a plunger. We have a sleeve. Okay, so we are going to get this lubed up. Okay. Get that in there. Put the new spring in. This is the old spring. Okay, and then we're going to put this in. Okay. All right, that looks like we are set. So now we're going to go to step 3, replace 4-spooled switch valve. No, part will only fit with units with 4-spool switch valve. Reference page 2 technical. Package pocket 3. A little bit different design. All right, note, Sonnax. This Sonnax part figure 3 will only fit units with 4-spool switch valves. These valve bodies can easily be identified by the tube that supplies oil to the boost valve. And that is what we have. Okay, so our next step is replace pressure regulator valve. Remove the OE pressure regulator valve and save for reuse. Remove and discard OE pressure regulator valve. Install Sonnax lube regulated pressure regulator valve. See figure 5. Return OE spring to bore, ensuring coils slide over the stem of the Sonnax valve. Okay. All right, so that one's in. And then this spring will go over that. Replace manual valve. Reinstall throttle pressure adjusting screw bracket. Reinstall parking sprag. Okay, so figure 7 is going to be, all right, we're going to go over here to number 5. Replace the manual valve, which is going to be right here. A little bit different. All right, I am going to just disassemble this a little bit further. I don't really have directions on what is beneath here, but separator plate modification. Drill TRE orifice to 62 hundredths of an inch using the Dremel. Open exhaust port slot to 3.5 to 4/10 of an inch for gas. 4.5 to half an inch for diesel. Okay, so I have this back together here. We have this this piece back in, but now I need to do a couple things here. And what we've got is got to drill this hole out We have the orifice drill bit here, number 6, I believe. All right, so we drilled out the hole and made this exhaust tab a little larger. All right, and this bottom is actually a rubber seal instead of a... What we need to do is we have our remaining springs and shifters. All right, finally, we have this sucker in. This is our governor assembly, and take a look here. We took all these pieces apart here. The one thing that I did notice, so we did have a potential governor issue. You can see here we got some rust, and prior to disassembly, and what really led up to the disassembly was that when the transmission would heat up, 2-to-1 shift would not occur. So I come up to a stop sign, it won't shift, downshift. And then if I manually went to first gear, then I could start off from first and then I would shift. It would have a flare. After using the truck for a while, like driving at about 80 miles on the freeway, the 2-1 shift started to work again. But it did have kind of a separate weird thing going on. Like it still would flare occasionally. So because of the age, because this is actually the second transmission this truck has had, I wanted to go through and refresh it while I had the opportunity and time, rather than, deal with this on the side of the road or, when I need it the most. So we'll get this cleaned up here. I'm going to see what options are available. Like this rust is coming off, but I want to see what options are available for this governor stuff and see, if there's any upgrades available. go from there. But in the meantime here, I'm gonna take some snap rings off, and we're gonna disassemble this a little bit more. All right, so next here we have, this is out of the overdrive unit. There is a big spring in here. We're going to compress this down and remove the snap ring and pull this apart. Clean it, put it back together. Okay, we are going to go back together here with this death spring, and we've got our new bushings in place. Looks good. Everything's been cleaned up, and All right, we are back at it. We are going to reassemble we are replacing the rings on the pressure governor, or pressure governor. Okay, we got these rings replaced, and all I did was make sure that they're offset. We don't want the joints lining all up at the same spot. But these are Teflon. These are like Teflon rings where these are metal. The bore that this all fits in is, for the most part, it looks fine. It doesn't look like there's an issue, but all right, this here has some corrosion on it, and I'm just giving it a good cleaning. Cleaning it up here with a little bit of 400 grit sandpaper. This truck sat around a lot, so it's entirely possible that we had transmission fluid with high moisture content. All right, we're reassembling the hydraulic governor assembly here, and I'm just making sure we get this correct. So this one had a lot of, I shouldn't say a lot, it had some corrosion. I believe it was actually stuck at some point, but sucker goes this way. Where are we here? All right, the valve that went back looked like the coating on it is still there, so I am going to not purchase a new one. We're going to leave it. It doesn't look like it's mushroomed out as described by some other rebuilders, so that is what we are doing. All right, I had started assembling this in the case and got a little bit ahead of myself. So the issue is going to be there is a wavy snap ring in here that is going to require a little bit of press. So we are... All right, the original clutch pack for the direct clutch that came in this transmission, these steels are thicker and we're almost 7mm. And the replacement clutch pack that I came, which if my memory serves correctly, it was some type of power pack. It comes with 2 more of the friction and 2 more steels, but the steels combined were down at 5mm. So when I do the size of this entire setup here, this, I guess we were able to get 2 more frictions in, but we're still under the size. I don't know why. Originally I was saying this was measuring at 25 and I went up to 28, but I'm actually 2mm shy. So we're okay. Never mind. This is what happens when a person takes things apart, walks away for a month, and then comes back. right, I'm going to replace this steel here because all right, and our final step here is we need to measure the gap here. The original measurements on this took into account a 1/2 inch bar, and this is 1.5 inch. So here we go. We're going to go down. Okay, 2.97. 2.97. 2.95. 2.96. So will be 1.96. And 1.96. Okay, so what I am going to do here, we are going to work on verifying whether this overdrive unit is going to be set up correctly. And I'm going to put a bar across that is 1.5 inches wide. And we're going to measure down here into the depth. And let's see if we can get this to show up. So there is a bushing that goes down here, and then there's another lip. That secondary lip is the bottom portion where this collar right here, which is the spacing collar, sits on. So we are trying to figure out the depth going upwards on whether this is all correct or downwards. So what I'm going to do, so right here, this is a 1/4 inch thick. .5 is the stated length of the Miller special tool that would insert here and allow you just to do a quick check on it. So what we are going to do, we got 513, it would be 8. So we're at 0.81. 0.81. Let's check our chart. All right, so we are about 1/100th of an inch outside of the end play measurement selection chart, but that's going to put us at 0.21 to 0.211 to 0.212. So let's just measure this here and see what we got. I want to make sure that we're not screwing this up. So this thickness is 0.277. We're going to set that right there. We're going to go down, down, down. All right, so we basically are at 4.44. Okay. So if I take 4.44, and then I measure here, .44, and then we go plus 1.616. Okay. Then we are going to subtract minus, what did I say this was? .28. Yeah, 0.28. That puts us at 5.776. So then we're going to minus 5.5. That puts us at 0.276. .4370. All right, 4.40. 4.4. 4.4. 1.62. Then what we do is we're going to add 0.28 plus 0.22. That gets us a half an inch. We go minus 5.5. Nope. Hold up. Okay, so the first time I measured, I used that file that was kind of rough and not perfect, and I came up with 0.81. Second time I measured, I kind of broke it out, as you could see, and I came up with 0.76. And the third time I measured, I came up with 0.78. So I am going to jump over to our things here. So 0.76 to 0.78 puts us right at 0.193 to 0.194. We are exactly where we need to be. This is 0.1935. So we're going to go ahead and put this ring back on, and we are set there. Now, the only other thing that I do need to do is we need to figure out the end play distance here. And so we're going to just drop this down. Okay, and 1.74. 1.73. .74. 1.74. So I think that is what I'm going to go with. And we're going to take 1.74 and we're going to add 0.22. And we're adding 0.22 because this is 0.28 thickness. And the bar that they set up the test for, the special tool, is a 1/2 inch thick. So we just need to add 0.22 and we end up with 1.96. So here, jump back over to our measurements and we've got 1.96. So we are kind of off the chart. I don't know what that means. Okay, so what I did here, we're going to just quickly talk. My setup came with this reaction plate right here. And as you can see here, there's a sort of a technical setup here explaining, what you can basically do. I just basically jumped to this right here and removed this reaction plate. It's about 0.215. So we got rid of that, which that lines up with the later versions here. And I just replaced it with 2 frictions, or I should say 2 steels and 1 friction additional in this pack. So this is set. The only thing that I am having a hard time finding information on is how much slop there should be set up in here. We are basically, there's a little bit more play in here than there was before. So I'm hoping we're okay. I'm going to continue to research it, see if there's anything. There's absolutely nothing in this book that I can find discussing, how much play there should be. It's only discussing the end play setup. So when we jump over here to the overdrive spacer measurement, so what I did was I like to use these, and I take my digital caliper, the end of it, and I poke it down, and basically I use the outer edge here, or where the bearing rides, and I take the digital caliper down, and we're going to get roughly about 1.56, 1.57 in there. So we get that. Okay. Then what I do, I took the thickness of the measuring plate that I was using. So the measuring bar, which is what I used, was 0.215. So I subtracted that and came up with a net 1.345. When they give you the information here, everyone is stating that it's these numbers take into assumption a 1/2 inch measurement bar. So what I did then was I just added a factory bar of a 1/2 inch, and I got a net 1.845. Go down here to 1.845. This is our range right in here. So it's 0.198 to 0.20. That is the thickness that we want to have. Now, what I ended up doing, the shim that came with the transmission itself was large. Basically, I think it was set up wrong from the get-go. But 2.2135, this is too big. So what I did here was ordered this kit, right here, and it comes with these 3 shims and a smaller version. So see, we got 1.1745, and then for my particular setup, we're going to be looking at right there 0.195, and that's going to go right in here like so, and that would be, we would be set up then. So that is what we have. All right, using a sheet metal screw, remove the OE cup plug from the OE immediate shaft and discard the plug. Using the steel rod, drive the OE shaft pilot out from the cup plug end of the OE immediate shaft. Figure 15. What is that? All right, we got that one out. Now we gotta get the end pilot out. Got that out. All right, we're gonna spray this out quick. I lost it, but I found it. That was a miracle. That truly was a needle in a haystack. That little thing went flying. I knew it was going to go flying. I shouldn't have done what I did, but I did it anyways. All right, so we have a new pilot bushing, smaller hole. And then we have a new end plug, which you'll have to trust me, it's a smaller hole. Install rear planet end play shims. If inspection of the rear annulus gear or intermediate shaft indicates visible wear, the Sonnax end play shim is generally required to use gear tray end play. To verify, measure the end play of the rear planetary gear, annulus gear, and driving shaft as an assembled unit, illustrated 18. Okay. Sand the assembly upright with the snap ring installed on the flat surface. Pull upward on the intermediate shaft and then measure the clearance. Insert a feeler gauge between the rear analyst gear and support hub of the intermediate shaft shoulder. The factory specification for the clearance should be 5 thousandths to 48 thousandths. A minimum of 5 thousandths to 10 thousandths end play is preferred. If the clearance exceeds this specifications, Sonnax end play shims should be inserted between the OE tabbed thrust washer and rear planetary assembly. Okay, so we have got this assembly here and gone ahead, assembled it the way we wanted this. And so we're checking for end play here, and from what I can tell, I had about 20 thousandths, and they're asking for about 5 thousandths to 10 thousandths. So I disassembled it and installed one of these shims. This shim is about 10 thousandths, and we can just barely get it in. So we are right where we need to be. If I installed the second one, it would be too tight. So we're good. So we've satisfied the zip kit on this. Now the only thing left to do is need to update these. Not doing that, not doing that. Gotta install these rings. And so and we've gone and measured everything and we're good. Oh, we got a big ring too. All right. So just pop this out for right now. All right. That one is done. It's too big. Oh. All right, we need to get these servos cleaned up, which I just did, and then need to get them in the case. All right, we're back assembling this thing. I had the wrong size band. Luckily, the existing band was actually in pretty good condition. So some catching up to do here. So it's not helpful to be jumping in and out of this project and then, you know, sort of remembering what we need to do here. So we have our rear clutch, and the rear clutch as it sits right now, because the new clutch discs that I bought are thicker, they do not fit correctly. So what ends up happening, this is a selective snap ring that would go into this hole over the top of this plate, and then there is a certain amount of play that needs to be in here. Unfortunately, that is not possible because these friction materials are thicker than what I need them to be. So rather than screw around with trying to get clutch discs that are thinner, what I ended up doing was I bought this Alto kit, and these have 4 of the Alto discs in them, but they are thinner. Not very thin, but much. I don't know if that is going to show correctly. Definitely thinner. And then it comes with the correct metal plates right here. And it comes with the correct snap ring, which is definitely thinner than what I have. So for $60, this all works. So let's, before I get too excited, all right, we have 0.4530. 0.4530, and then this is 0.0615. And come over here. So all right, we almost have almost a 1/10 of an inch difference on this clutch pack with the old one. And then we come over, I said that snap ring was 0.06 and this one's 0.08. Oh, look at that. It works. All right, we've got we have a proper feeler gauge here. Okay, 31 thousandths. That's pretty tight. I don't think I can get much more in there. That's 34 thousandths up to 55 thousandths. And the low end is 31, so we're right. go. All right, that portion is in. Now I need to install the front band. All right, I get tired of, I really have a hard time sealing these bottoms out without having to glue the crap out of them. So I went ahead and did an investment on a reusable seal, and it's been on the vehicle once and it didn't leak. So I was happy about that. And now we're gonna use it again. All right, so we're not perfect, but for the most part, case is cleaned up. We have our bearings out. We're going to start going back in with the new ones. And I am going to start right here. Our new process transfer case, it's a 241 DLD out of a 94 Dodge Ram. Because the transfer case was coming out, because the age, I thought it was probably prudent to just at least go through it and make it as good as we can make it. So that is what we're doing today. We got our bearing, one new bearing in, and then so this is the main shaft here, and what I'm gonna do is we're gonna cut this seal off. It's the old one. Put that right there. All right, and then just gonna move this out of the way for right now. Need to clean up this, get this shaft cleaned up here. Okay, we're gonna go clean this sucker up here. Move this out of the way. All right, we're gonna fit this in here. We'll come back to that, get everything torqued correctly when I bring back the torque wrench. Clearly, I screwed up. so we're going to retorque this at a later date. Oh, there we go. All right, in my kit here I have found a close match, but not an exact match, seal. But I think we are still, I think we're doing correct here, but okay, we are back and ready to go here. We're gonna mount this, I believe, right about here because we got this right here in this hole. So I believe this is like a drain back for fluid that's built up. I don't know if this fits any other way. It doesn't really fit any other way. It fits this way though. So. All right, so what we're going to do here, I'm going to use Hylamar to seal this. I am just kind of coming along. I'm going along the bead here. It was coming out normal, and then all of a sudden it became, the consistency changed. Like there was a oil pocket, and not super happy about that because it doesn't seem to be sticking quite as well. So I don't know. Just going to kind of drag things along here. There we go. Now it's going in nice. I think we are good here. The only thing I'm going to do quick is we got a little drain or supply, one of the two holes for the bearing. I think it's a drain, but I don't know. Got that cleaned out. We sealed our bolts. As you can see here, the bolts come through. All right, I think we are good. Okay, so probably the biggest component to this is why the shift on the fly never really worked in this truck. Never worked for as long as I was aware. So I'm thinking the blocking ring synchro is ultimately what is the cause. But looking at it, I can't tell you why that would be. I mean, this looks perfectly fine. The only thing that, yeah, I don't know. Not really, not super confident. I don't know. That's pretty close. Probably may need to order a new chain, but opportunity presented itself, so I did.